Welcome back, ladies and gentlemen. Today we're going to tackle the second half of 5.5, solving more trig equations, but this time we're going to solve the more difficult ones, the ones that require factoring. As a reminder, this is part of a 2-day segment where we split up one section into 2 days. We're now on day 2, so the assignment you'll see up on the screen now. Today we're going to see a variety of slightly more complicated problems, and we're hopefully going to get the problem to look like what I have up on the screen right now by doing a little bit of work. In most cases, you'll have to do a little bit of work to the problem before you get to this point. But I need you to understand what this sentence says right here. It says, thing 1 times thing 2 equals 0. And I want to remind you of something called the zero product property, which is kind of the basis by how we solve any problem with factoring. And it just simply states that if you have two things multiplied together and their product is 0, then you know at least one, maybe both of those two factors could be 0. So you set up two equations independently and you solve for each possible outcome. So if we look at a problem like this, what it's saying is, here we got thing 1, here we got thing 2, so we're able to recognize that, hey, it's in A times B format. That means either A has to be 0 or B has to be 0, and I'm going to write an equation that says either thing 1 is 0 or thing 2 is 0 independently, and then I'm going to try to solve each one of those separately. And you'll notice that when we break these down, we end up with a trig equation a lot like the problems that we were dealing with in the first section of this. So if I solve these just so that it's just the trig function isolated on one side, then I get tangent of x is -1 or sine of x is +1. And then I can go to the unit circle and grab that. This one requires a little bit more thinking. What angles have a tangent value of -1? Well, remember that if the tangent value is 1 or -1, that means that the legs of the triangle are the same size, which means that's happening at pi/4 increments. And in order for a tangent value to be negative, that's going to happen in either quadrant 2 or quadrant 4. Quadrant 1 and 3 are positive. So if we grab those locations off the unit circle just by thinking about the unit circle or kind of walking through that one, we get 3 solutions in total for this problem. 3 pi/4, 7 pi/4, and pi/2. You'll notice the second problem I have for you today is not written in something times something equals 0 format. It's close, but it's not quite there. And if it's not quite equal to 0, one of your first steps is going to be make it equal to 0 and then do stuff to it. And even more telling is that I have one item in common to both terms. So you can see we're kind of in, if I were to simplify the way this thing looks, I have thing 1 times thing 2 minus thing 1. So it's kind of in this format. And you'll notice that there's a thing in common to both terms. Well, let's just factor it out. The way we would do it with this problem is we just pull out the a. Well, if I've got a sine x here and a sine x there that I can pull out as a factor, I can write it again just like that. And then all of a sudden I have thing 1 times thing 2 set equal to 0, and I can set two independent equations equal to 0 and solve each of them. So the one on the left, that doesn't require any solving. Whereas the y value 0, that happens at 0, pi, and 2 pi, but remember we're solving on the interval not including 2 pi, so we ignore the 2 pi solution to that. This one, just add 1 to both sides, and then again we're just thinking where is tangent equal to 1. So either a tangent table or that happens at pi/4 increments in quadrant 4 and quadrant 3. So the answers would be pi/4 and 5 pi/4 for that one. Take a look at this problem. You'll notice that we have 3 terms now. There's no multiplication happening necessarily. Maybe you could talk about cosine times cosine in that cosine squared terms. But other than that, I want you to think about this as a trinomial. Pause the video and see if you can come up with this with the next step for this to see if you can simplify this in a manner that would allow you to solve it. Now, if you look at this trinomial as a trinomial, you might notice that you have kind of the situation like you would have like a normal trinomial with a variable in there. You have something squared, a term with just that variable, and then you have a term without that variable. So in other words, if I just kind of simplified it, I'd have a trinomial of this format, and this is something you can factor. Now, you should have a tool in your toolbox for factoring a trinomial. You need to be able to handle factoring that in any way that you can do it. In our building, I know that we've used the X method pretty regularly, so here's the template, and remember the idea here is put the a value times the c value here, the b value here, and the a value times the variable that you're dealing with on the top of these two fractions. So if we set that up, this one looks like a -2, a 1, and then a 2a and a 2a. And your job is to come up with a pair of numbers that multiply to be -2 and add up to be 1. You put those numbers in the red question mark spot, and then you simplify any of these fractions that are possible to simplify. This one is, so you simplify that to a over 1. And what this means is that the factored form of this trinomial is a plus 1 times 2a minus 1. So it looks like this. Again, you can use the asterisk method or the x method or whatever you want to call it. You can use guess and check. You can use whatever method you want, but you need to be able to factor something like that. And once you have the solution to the factored form, then we're kind of in familiar territory. Remember, I kind of simplified the problem by introducing that a term. Well, now I'm going to bring the cosine back. I'm just going to put the cosine everywhere there was an a. And now you can see we're definitely in that format of thing 1 times thing 2 equals 0. So I can then write two little equations, independent equations, that are each set equal to 0. Now we want to again isolate the trig function in each of them, so we have to solve them. And where's the cosine value of an angle 1/2? Well, that happens at pi over 3 and 5 pi over 3. And then where's the cosine value at -1? That's at pi. At this point, I'd like you to pause the video and try one yourself. Okay, I'll run through this one real quick. Again, I would take the time just to simplify this, just so you can recognize it as more familiar math. If you can handle factoring it without writing this line, go for it. And then you have to be able to factor that trinomial in some format. So if you factor that correctly, you have 2a minus 1 and a minus 1. So once you have factored form, then you can write out two equations. We're going to sub back in that sign, and that would look like something like that. So we have two independent equations. Isolate the trig function. So on the left-hand side, we're going to add 1 and divide by 2. On the right-hand side, we're going to add 1. And then we're going to think on our unit circle, where does that happen and where does that happen, if at all? So right here, that happens at pi over 6 and 5 pi over 6. And right here, that happens at pi over 2. Here is our last example. Please pause the video and copy this one down in your notes. Now right away, this problem should look significantly different than the other problems. You'll notice that there's only two terms, and more of an issue is that those terms don't have anything in common in terms of a trig function, and the trig functions don't match in any respect. There's not more than one term with a sine in it, and there's not more than one term with a cosine in it. So we're kind of stuck right here until we do something clever. We are going to make them match using the Pythagorean identity. So I'm going to grab the Pythagorean identity, and I want to come up with a different expression for sine squared, preferably all in terms of cosine. So if I want to solve for this, so I can sub it back in there, what I want to do is I want to get this over to the other side. So subtract a cosine squared, and then sine squared will end up looking a lot like that. We're going to take that chunk and sub it into the equation right there. So if you sub in that expression appropriately, it looks like that. Remember to use parentheses here, because if you forget to distribute, you just won't get an answer. So distributing that 2 onto both terms, and then you'll notice that I have a positive 2, a negative 2 cosine squared, and a 3 cosine. Now, I'm not very good at factoring when my leading term is negative. It's totally possible to do, but I just suck at it. So the first thing I'm going to do is I'm just going to rearrange these terms so it's cosine squared, cosine, and then the integer. The other thing that I'm going to do is, because that leading term is negative, I would like that to be positive. So I'm going to multiply that everything by -1 and rearrange stuff. And once I'm done doing that, it looks like this. 2 cosine squared plus 3 cosine minus 2 is equal to 0. Then I'm going to take my best shot at factoring that, which you can simplify or not, but one way or another you need to factor it into those two terms. And then we're in familiar territory again. So we can write two small independent equations, solve each of them, and go find the places on the unit circle where each of these is true. Now, the problem with this one is that this is actually never true. We have a cosine value of -2. Remember, cosine goes from -1 to +1. Every angle has a cosine value between there. So a cosine value of -2 just doesn't make any sense. So that's garbage right there. And you will get some garbage answers occasionally. So we're going to cross that out and just write down the solutions from the equation that actually gets something solved. Again, here's your homework, and I'll see you next time.